Hey Science 9, Mr. Lum again, and we're going to be moving on. Last time we did a lot of definitions for current electricity, and today we're going to be getting into some more current electricity and drawing some pictures and that kind of stuff. Anyways, let's jump into it. So the first thing about current electricity is that current electricity, or in other words, an electric circuit, is a complete pathway that allows electrons to flow in a loop. If you remember last time, we talked about what is like a battery or a cell and how does it kind of work. And without getting in too much kind of the chemistry of how a cell works, essentially what a cell is there are several different chemicals inside of it. Some chemicals want to lose electrons and give those to others. And if we had like a chemical that wants to lose an electron, let's take something like lithium, and this is some chemistry. So lithium has 2 electrons on its inner shell and 1 electron on its outer shell. Now normally lithium wants to become more stable and turn into Li+. So in other words, it wants to lose 1 electron. So it wants to lose that 1 electron. Now, if we can make lithium, or some other chemical for that matter, lose that 1 electron in a very specific way, we can make electricity. So if we can make that lithium lose that 1 electron and make it travel through a wire, so lithium loses that 1 electron and that electron travels through this wire, and then it might turn on a light bulb. Okay, so here's our light. Might turn on a light bulb, but it still needs to go through that wire and react with that other chemical that's inside the battery, or in other words, the cell. And so that's why there needs to be this circuit. It needs to leave, and then it needs to also come back to the cell. Okay, and that is why we call it an electric circuit, because there needs to be that complete pathway for that loop to form, for electrons to flow in a loop. Now, a load is a device that changes electric energy into another type of energy. It can change into light. So this example that I did right here, it changed into a light. It can change into heat. So you can, instead of having a light there, you can have a heater, or you could have a motor there to create motion. But all of those things, having a light, heater, motion, or whatever it may be, that's called a load. So before we jump into some of the calculations of electric current and that kind of stuff, we're going to be making and drawing some electric circuits. So here's an example of electric circuit. Okay, so we can kind of see everything that's in there. Here we have a cell, which is commonly called a battery, but technically it's not, and we'll get into that a little bit later. So that's a cell. These are light bulbs, of course, so here's some lights. And then this is a switch to turn on the lights. Okay, so we have another switch right here. So we have 3 lights, 1 battery, and 2 switches right here. Okay, and then we have a bunch of these wires. Sometimes we call these leads. Now, if I was to say, like, let's draw some circuits, it would take a considerable amount of time to draw a circuit like this. So we have some shorthand kind of ways of drawing some different circuits and that kind of stuff. And so we're going to learn the symbols for drawing electric circuits. So the first one is an ammeter, and we haven't talked about ammeters yet, but an ammeter measures how many amps are going through the circuit. And we will talk a little bit more about amps later and what amps mean. But for right now, the symbol for amps is just the letter A with a circle around it. Okay, so a voltmeter is the letter V with a circle around it. A voltmeter measures how many volts are that is being being produced from the cell or whatever. Now a wire is just a line like that. Okay, so technically these are coming off of the ammeter are wires or leads as well. Now a cell looks like this. So we have a wire that goes into a cell, and then it'll have a little line like that and a big line like this. Okay, so that would be a cell. Okay, so that's a cell, and I'm going to redraw the cell over here. A cell would be, so here's a cell. Now a cell is drawn like this, and the other thing about it is that this long side right here, that's the positive side. And this small side right here, that's the negative side. Okay? So this would be one cell. This is the symbol for one cell. And this would be the symbol for two cells. Okay? And then this would be the symbol for three cells. Oops. Okay? So one cell, two cell, three cells. Okay? Now, a cell looks like this. A battery is just more than one cell. So a battery is, well, here would be a two-cell battery. And this would be a three-cell battery right here. A light looks like this with a circle around it. Kind of looks like a light bulb. Okay, one of those old-fashioned light bulbs. Now a switch kind of looks like a little mini, like a door or something like that. So it's kind of like, so here are two leads and a switch like this. Now the idea, the picture behind a switch is that it looks like a door that can open and close. And if you close it and that means it's a closed circuit, and if it's open like this, that means it's off. So if this is in this position, it would be off, and if it was like in like this position, it would be like on. Okay, so if you ever break the circuit, it'd be kind of off, and we'll talk more about that later. A motor has this kind of picture. Three dots. And a resistor kind of looks like this picture. Okay. So if we were to draw, I'm just going to erase some of this stuff right here. If we were to draw a circuit, if we were to draw a circuit like this one right here, it would take forever to draw this, but if we were to draw it using these symbols, it's much, much quicker. So a cell, so this would be a cell. Well, we look up what a cell is, and it's just the negative side is right here, and the positive side is right here. So I'm going to write the negative side like this, the positive side like that. Then we have some wires coming out of it in both directions. Okay, so these wires right here coming out from both directions. So we're going to draw those wires coming out in both directions. Okay. So the next thing is that after the positive side, right here, after the positive side, it's going to be hitting this light bulb. So I'm going to draw a light bulb, which looks like this. So there's our light bulb. Then after the light bulb, it hits this. We have another wire right here. And then after that light bulb, it gets into a switch. So a switch looks like that. So we're going to draw that switch. So I'm going to erase that. So we drew that switch. And then now we have these two light bulbs right here. So we draw those two light bulbs right there. Okay, and then we have another switch right here. Well, in between there's a wires, but then we have another switch right there. So I think I'm going to draw this switch going up like this. And then back to the battery, or the cell, I should say. So it's much quicker to draw a picture like this. It's also easier for electricians and people to read than a picture like this. When you're drawing your wires, you usually want to draw them either horizontally, perfectly horizontally across, or straight up and down. That's how you typically draw your wires. And yeah, okay. So today's lesson is going to be all about learning how to draw electrical circuits. So we just did this one. So this is how fast I would normally draw it. Okay. Now, one thing that I want to emphasize is this picture right here is the same as this. Okay. Now I'm going to draw another one right here. Now I just moved the light bulb. I'm going to move the light bulb rate a little bit higher up. But these are all the same. Okay, so it doesn't necessarily matter that I moved this light bulb up to this location right here. These pictures are all the same. Okay, so it doesn't really matter if you think that this light bulb should be at the top or on the side or whatever. Technically speaking, that these pictures would be considered to be the exact same picture in the terms of circuit electricity. And if you want, you could even draw it looking like this. So So even this one right here these are all the same picture. Okay, now they look very, very different, but I want us to think about this. It goes from the positive terminal, so this one goes from the positive terminal. I'm going to use a different color here actually. So it goes from the positive terminal, it goes through one light, through a switch, through two lights. This one goes from the positive through one light, through a switch, through two lights. Okay, and then this one goes back to a switch, and this one goes back to a switch, and then back to a negative, and this one goes back to a negative. So as long as the order is the same in the way that you're speaking about it, then it is the same picture. So these are the same picture. So it went from light, switch, light, light, switch. This one goes light, light, switch, light, light, switch. This one also goes light, switch, light, light, switch. So all three of these pictures are exactly the same. You would never draw these the purple parts. So this is what you would actually be drawing, and this would be, if I asked you to draw this picture, this would be your answer, or a variation of that. But as long as it hits the same order, then these are all the same picture. So you have your notes right here, so hopefully I would like you to draw your pictures right here. Now, whenever you see a cell like this, if it's like a typical AAA battery or something like that, the part that has that little nub part on the battery, this is your positive end, and this is your negative end. Now, before we drew it like our cells like this, okay, and the negative was on that side, well, you can also draw it like this. There's no problem with doing it this way either, okay? So this is the positive end is on the left side now. So, and then there's a switch. Here's our switch. Switch turns it on and off. And it goes through a light bulb. And then back to the other. So that would be a picture of it right there. Okay. Now, if you drew something like this as well, this would be also just equally as right. Okay. Okay. So now that we kind of understand a few different things, we're going to go on to another definition. Okay, so the first one right here is a definition is the term series. Series means there is only one path for the electricity. So if the electricity is traveling around, right, it can only go through here. The electricity must go through, the electrons must go through this light bulb right here. Then it must go through this ammeter. Then it must go through this light bulb. Then it must go through this one right here. Okay, so this is called series. Now, here we have a battery. This is a 3-cell battery. We have that same 3-cell battery right here. And so let's say it's coming down right here. Now it gets to this junction right at that spot right there. And it has a choice. It can go in this direction right here and then go back, or it can continue going down in this direction. So since there is more than one pathway, there is a choice for the electrons to travel, or which way the electrons would like to travel through the wire, we say that that is called parallel. Now I know that parallel means two lines that run beside each other that never intersect. But in circuit electricity, it just means there is more than one pathway for the electricity. Okay, so even though here's their next one is going back here in this direction, and then it's going to go, it can go back in that direction. And there's a whole bunch of different things that are in parallel right here. Okay, now if you remember, this V is a voltmeter. It measures how many volts are going through there. Now, I want to emphasize this, and this is maybe a little bit of a mistake for me. These sections right here, these are all in parallel. Okay, the electricity may choose to go through this light bulb, or it may choose to go through this voltmeter, or it may choose to go through this light bulb, or may choose to go through that voltmeter. Okay, so that's why these are parallel. When they come back to the battery, they must go through all three of these cells. So all three of these cells, since it must go through those, there's only one way it can get through here. These three cells are called being connected in, these are in series. That's going to bring us to our next point, is right here, is that this is connected in series because the electricity must go through this ammeter. But when it comes down here, it could go through these ammeters, it could go through that ammeter, or it could continue on going down through this ammeter. And then it must come back up here and back into our battery. So this part right here is also connected into series. Okay. So we're going to take a look at some different examples of drawing some of these things, and you can follow along with your notes and see if you can draw it as well. And we'll look at some differences between series and parallel as well. So here we have a question, and the question would be like, please draw this. You have 3 cells, an ammeter, a voltmeter, a switch, and a bulb all connected in series. So I'm going to draw the 3 cells first. So 1, 2, 3. And since it's all connected in series, that means the electrons must go through each one of these things. So here's our ammeter. Here's our voltmeter. Here is our switch. And we'll draw a light bulb right down here. And then it has to go back just like that. Okay, so this would be a completely right answer. Now, if I drew it like this, so 3 cells, ammeter, voltmeter, switch, light bulb, and then back, this would also be completely correct. So both of these would be completely correct. Now we have a thing that says 3 cells connected in parallel. So this is when 3 cells are connected in series. The electricity must travel through here. So we have to make sure that these 3 cells, the electricity has an option, or the electrons have an option of going through those. So now, I'm just going to do this in purple. So if the electricity is coming through here, okay, it now has an option of going up this way, straight through this way, or can go down this way. So since it has options, we say that these 3 cells are parallel. Now, so let's keep on going on. So we have 3 cells connected in parallel. I know it looks a little bit different, and I'm going to come back to that in a bit. The 2 light bulbs are also connected in parallel. Now it has to have that option, so we're going to draw it down like this. Okay, so when the electricity is coming down, it could go this way, or it could go this way. So as either choice, we say that's parallel. Now, I didn't talk about this before, but when you're connecting cells in parallel, you must make sure that all the negative sides, so we'll do green, here are the negative sides. The negative sides must be connected to each other, okay? And the positive sides must be connected to each other as well. So if you had a cell and you did this, so here's negative and then positive, and then you went like this, positive and negative, and you connected these things in parallel like this, but you connected the negative and the positive together, well, this is bad. You can't do that, okay? It'll short circuit out your batteries, and you're not supposed to connect stuff like that. Because then the electrons are just traveling from one cell into the other cell, and that could be a little bit catastrophic. So if you've ever had to jumpstart a vehicle, or you had to connect one vehicle's battery to another vehicle's battery, and you did it correctly, you should know that you should go the black to black and the red to the red. Or in other words, you should be connecting the two positives together and you should be connecting the two negatives together. Okay, so if you have a car battery and you are jump starting your car battery, and you have one terminal that is positive and one terminal that is negative, and you have another car battery over here, and again, positive to negative, and you need to jump start your vehicle, so that's where you take the wires and you connect the two batteries up. You must connect it from positive to positive and negative to negative, like that, okay? If you connected it like this, positive to negative, and this other positive to negative, well, that would be pretty bad, okay? Don't do that. Okay, next one here, we have 3 cells connected in series. So that means we're going to go 1, 2, 3. Okay, and then we have 2 lights that are connected in parallel. So that would be our answer, something like that.